In this video, we'll start from zero and explain what a tree is in data structure, why trees are used, all the basic terminology like root, parent, child, and leaf, and then we'll finish by explaining tree traversals, Inorder, Preorder, and Postorder. This is a core topic for computer science students, especially for exams. Let's compare array versus tree. Why trees exist? Okay, so imagine if your data is stored in array like this, or a tree like this. If you want to go to H, you're gonna have to go through every element, A, B, C, D, E, F, G, then to go to H. However, in a tree, all you have to do is go from A to B to D, and then you reach H. So you had to go only through 4 elements instead of every single one. Now, on a long list of tree, on a very big data, it will see a big difference. So basically, the ability to skip large parts of the data is why trees are much faster. That's why trees are used in databases, file system, and search engine. So for example, in this file system on your computer, it is stored in a tree-like structure. So what is a tree? A tree is a non-linear data structure made of nodes connected by edges. This top node is called the root. Every tree has exactly one root, and the root has no parents. A node above another node is called a parent. Nodes below it are called children. So nodes below it are called children. So as we can see, B is a parent node to D, and the child node of B is D. The same way, the parent node of D is B, and the parent node of E and F is C. So what does that make the parent node of B and C? It makes it A. Now I want you to pause this video and answer this question. What is the children of D? The children of D are G and H. Now, what is a leaf node? A leaf node is a node that has no children. So in that case, what would it be? It would be G, H, E, and F. Also, as we said, the root is the top of the tree. We also have to know that any node can be the root of a subtree. So the tree has many trees. Basically, if we right there, B is the root of this subtree. Its children, which is D and which is GH. So B is the root of that tree. So now we left with depth. What is depth? Depth is the number of edges from root. So let us say we need to see the depth of G, for example. We can see that the depth of G is equal to 3 because it has 3 edges. What is the depth of A? The depth of A is 0. Now what would make the depth of C? I want you to answer this question. The depth of C is equal to 1. What is the depth of E and F? The depth of E and F is equal to 2. So the very easy explanation is to basically just count how many lines to reach the given one that you have to get the depth of. Now the height is pretty similar. To find the height of A, it's the complete opposite of how you find. So you just check the longest path to a leaf, which is G, because G and H and E and F are leaves, and the longest leaf is G and H. So you start counting from here. The height of D is 1. Okay. The height of G is 0. The height of B is 2. The height of A is 3. Now, what do we say about E, F, C? What is the height of E? Well, it's 0 because it's the leaf node. The same with F. Now, what about C? It's 1. Now, what about A? It's 3 because we take the longest leaf of that one, which is this one. Now we can move to traversals. So let us start with traversals. So first we have Inorder and Preorder and Postorder traversals. Let's start with the Inorder. So we start with the left subtree first, then the root, then the right subtree. So let's give this tree for example. The root is A. The left subtree is all the left subtree of A. The right subtree is all the right subtree of A. Then when we finish the left, we go to A, and then we go to the right. So for the sake of explaining, let us say that we are going to print whatever node we visit. Also, just to say something, A is not only the root, because we have subtrees inside. So A is the root of all this tree, but if we take this one for example, the root of this tree is C. The root of this tree is what? It's B. Of this one, it's D. So what is going to happen here is whenever we go to the left side, we're gonna be taking that one as the root of the subtree. So we're going to take a new subtree. In order, it visits first the left side, then it goes to the root, then right. So let's say we start at the root, which is A. The left side of it is B, so we go to that one. We don't visit it yet because B is now considered a root of a subtree, which is this one. So what we do is we go to its left as well. Now we're at D. Now D, we go to its left. We are now at G. Now G, we also go to its left. We find out that there is null pointer, so it's basically empty. So if it is equal to null pointer, so we finish the left. Now we go to the root. The root in this case is G. Like we said, this is its own subtree. So now essentially we can print G, because now we are visiting G. Okay, so now we finished visiting G. We go to its right subtree, which is null pointer. So now we finished all the left subtree of D. What happens when we finish all the left subtree of D? We finish its left subtree. Now we go to itself, which is D, and we print it. We are visiting D. So when we finish the D, we go to its right subtree, which is H. Now when we go to H, we check its left subtree, which is null. Then we check itself. So now we visited the root itself, which means we can print it. Now when we finish H, we can go to its right subtree, and we find out that it's also null. So we finished the right subtree of. So we finished GDH. We finished this. So when we finish the left subtree of B, we finish the left subtree of B. Now we go and visit B and print it. Now we go to its right subtree. We find out that the right subtree of B is null. So now we finished the left subtree of A. So now we reached A. We print that as well. Then we finished A. We go to its right subtree is C. Now we are at C. We check its left subtree. Is it equal to null? It's not. It's equal to E. So now we go to E. Now we check the left subtree of E. It's equal to null. So now we finish its left subtree. Now we go. So essentially now we visited E. We can print it. Then we go to its right subtree. It's equal to null. So now we finished the left subtree of C. So we can write C now. Now we go to its right subtree, which is F subtree. We find out that it's null pointer. So now we finish its left side. We go to itself, which is F, and then we go to its right subtree and we find out that it's also null. So we finish the tree. Now let's do preorder. The thing with preorder is that it first visits the root itself, then it goes to its left side, and then when it finishes going to its left side, it then goes to its right side. So in a quick summary, so we're going to go to A, we're going to visit A and print that number. Then we're going to its left side, and when we go to its left side, this is going to be the root of that subtree. So we're going to print that number as well. Then we're going to the left side, and yeah, that's it. So I suggest you pause this video and attempt to solve this. To not waste time, I will solve it quicker because now you have the knowledge enough to understand the rest. So first we went to the root, we print that. Now we go to its left subtree. The left subtree is now a root of that subtree, so we print that one. Then we go to its left and we print that one as well, because now the root of that subtree is D. Then we go to its left and we go to its root and we print that. Now we finish G. We go to its left subtree, we find null pointer. Then we go to its right subtree, we find null pointer as well. So now we finish the left subtree of D, and we finish D as well. So we finish D, its left subtree. Now we go to its right subtree, which is H. Now H is a root, we're going to print that as well. Now H left subtree is null. Okay, its right subtree is also null, so we finished H. We finished D as well, so now we're at B. We printed B, its left subtree as well, we finished that. Now we go to its right subtree, which is null, so we finished that as well. Now we're back at A. So we print A, we finished its left subtree. Now we go to its right subtree, so now we're at C. We print C, then we go to its left subtree, which is E. Now we're at E, we print that. So now we finished E, we go to its left subtree, it's null pointer, so we finish that. We go to right subtree, it's also null, we finish that. So we're back at C, we finish C, we finish its left subtree. Now we go to its right subtree, which is F. We print F, then we check its left subtree, it's null. We check its right, it's also null. So we finished preorder. So the postorder, we go to its left subtree first, then its right subtree, then lastly we go to the root itself. So for example, we're at A, we don't visit anything yet, we go to its left, then it has a left. So if it has a left, we go to the left, then we check left and it's null. So we finish the left one, we go to its right side, we check the right and it's also null. So now we finish the right. Now we go to the root, which is G, and we print that. Then we go to D, we finish its left subtree, then we go to its right subtree. So now we're at H. We check its left subtree, and that, and so on. So I will solve this. I want you to pause this video and try to attempt to solve this on your own. So as we said, we are at A, we go to its left subtree, then its left subtree, then its left subtree, then its left subtree. We find out that it's null. So we finish the left, we go to its right, it's also null, so we go to G itself and we print that. Now we finished G, we go back to D, so we finish its left subtree. Now we have to finish its right subtree so we can reach itself. So its right subtree is H. It does not have a left subtree nor a right subtree, so we visit H. So now we finish the left subtree and right subtree of D. So now we can visit D. Now at B, we finish its left subtree. Okay, we go to its right subtree. We find out that it's also null, so we finish that as well. Now we go to itself. We visit B and print that. So now we finished B. We finished the whole left subtree of A. Now we go to its right subtree, which is C. C has a left subtree, so we go to E, and E does not have a left subtree, so we finish its left side. Does not have a right subtree, so we finish its right side. And now we visit B. So now we finish the left subtree of C. Now we can go to the right subtree of, which is F, and since F does not have a left subtree nor a right subtree, now we can print F. Now since we finished the left side and the right side of C, now we can print. Now since we finished all the left subtree of A and all the right subtree of A, now we can print A. And that would be the finished. And now we finished all the traversals. So a quick tip on how to memorize the order of the traversals is you basically consider root as the main character, So now it's always left then right, and it's in order, so now it's in. So root is inside left and right. It's pre, so now it's before left and right. Now here it's post, so it's after the left and right. This is an easy way to memorize it. So in the next video we'll explain binary search trees and why trees become even faster. If you found this video useful, consider subscribing. Thank you for watching.